Okay, so let's see. We're going to factor with leading coefficients. The first problem, if we take a look at it, right here, 3x squared plus 4x minus 15, it does not have any greatest common factor that can be divided out of all of those three numbers. So since that's the case, we are going to do our x method. Up here at the top, remember it's going to be a times c. So here's my a, here's my c. That's going to give me negative 45. Then over here at the bottom, we're going to put the b, and that's going to be 4. Okay, so now I write out my factors of 45. I need to make sure I get 4. That would be 4 and 5. Okay, so 9 times 5 would go in here. So where the 9 and 5 are, we need a negative 45 when we multiply, but then we need a sum of 4, which means the 5 is going to be the negative. So over here on the, back to the original problem, when we write out our factors, so here we have the 2 set of parentheses. In the past, we were taking the first part over here, we were writing x and x. This is going to be instead, the 3x will come in this first part and the 3x will come in the next part. Let me do that. And then I need to bring over my plus 9 and minus 5. Okay, so now the next thing that we are going to do, which is also new, is we are going to look at each of these factors here, and we're going to do one at a time. So like if I take a look at the 3x plus 9, I need to try to see, is there a number that can be divided out of both of those and simplify it? And the answer is yes. I can divide a 3 out of both. When I do that, that now is going to give me x plus 9, and the other side will be 3x minus 5. The reason this second part did not change over here is because between the 3 and the 5, there's no common factor, so you can't divide anything out. Okay, so since that's the case, here is your final answer. And we know that because if we were to actually check our answer by doing the distributing, it will give you back the original 3x squared plus 4x minus 15. Okay, so now if I go to the next problem, on the next problem, you see, make that a little bit bigger. Okay, so I will look to see first if there's any greatest common factor between any of these terms, and the answer is no. So then I go ahead and I do my x method over here. Okay, remember a times c. A is 10, c is negative 8. This is going to be negative 80. Then at the bottom, I'll put my b, which will be the 11. If I come up with my factors for negative 80, well, I know that for 80, I have 2 and 40. There's a bunch of other ones. There's what, like 8 and 5. That, oh no, I take that back. It is not 8 and 5. It is 8 and 10. And also, the ones that's going to work here will be 16 and 5. Okay, so 16 and 5. Then I need a negative 80. So one of these two numbers has to be a negative, and it also needs to equal a positive 11 when you add them. So the 5 will be the negative. Okay, now I go over to my factors, and when I write out my factors, the 10x is going to go at the beginning. So 10x, 10x, then I have plus 16 and minus 5. Okay, so same as before, I need to look at each of these sets of parentheses. Between the 10 and the 16, I can actually divide out a 2. So when I do that, that's going to get me now 5x plus 8. And then on the other side, if I look at the 10 and the 5, I can divide out 5 from both of those. So that's going to give me 2x minus 1. Okay, so there is my final answer. All right, so now I'm going to go ahead and look at the last problem. And on the last problem, when we look here, 24, 42, and 9, they actually do have a greatest common factor that can be factored out of all three of the terms. And that's going to end up being 3x. Okay, so if 3x is going to come out of each, it's basically like, okay, just keep in mind you're dividing out 3x from each of these terms. Okay, when I do that, it's going to give me, at the beginning, 8x squared. Then I will have negative, don't forget the negative 42 divided by 3 is going to be negative 14. And then x squared divided by x is x. Okay, and then last we have 9x divided by 3x, which will be positive 3. Oh no, positive 3. Okay, then I need to take the part in the parentheses, the quadratic here, and I'm going to go off to the side, and I'm going to do my x. And here, so 8 times 3 is 24. Then I have negative 14 down below. If I write out my factors of 24, when I think about that, it's like 3 times 8, 6 times 4. But the one that we're going to need is 12 and 2. Okay, so when I look at this, I need 12 and 2 when multiplied to equal 24, which it does, but 12 plus 2 does not equal negative 14. That means both of these need to be negative. Okay, so back over here, I'm going to write out my factors. Bringing down, actually, don't forget the 3x. And then I'll have my two sets of parentheses. 8x will come first. 8x and 8x. Then I'll have minus 12 and minus 2. Okay, so now this 3x, nothing is happening with that 3x. Don't multiply it out. Don't forget about it. Right now we are just going to do the simplifying of these two sets of parentheses, okay? So between 8 and 12, I can divide out a 4. And between 8 and 2, I can divide out a 2. So when I have that, I'll bring down the 3x. 8x divided by 4 is 2x. Negative 12 divided by 4 is 3. And we have 4x minus 1. Okay, so there is your answer for this one. Now, if you get this problem and you try to check it, like, how do I check one that has 3 multiples? Well, you can do different parts. I'll do the binomials first, so that would be 8x squared, 2x times negative 1, negative 2x, negative 12x, and positive 3. you can then multiply everything by 3x. So that would give me 24x cubed minus 6x squared minus 36x squared, and then plus 9x. Combine your like terms, and you have 24x cubed minus 42x squared plus 9x, which gives you back the original answer, so you know this was correct. All right, sorry if this video was a little messed up at times. I tried my best to redo that other video without having the proper software here at home. Okay, let me know if you have any questions.